Okay, so today we're going to be doing the gram to gram stoichiometry calculations. And so let's start with just a little bit of reminders of what we're going to be doing with this, okay? So when we're doing gram to gram, all that means is that we are going to be, this is just a little silly map that we've been looking at. And so what it means is that we're starting over here in something we call a gramland, okay? And so our reminder with gramland is that we have to use our molar mass in order to convert to the moles, right? And so when we are going from grams to moles, remember that setup is going to look like we have grams at the top, we bring words down to the right, so we're going to be dividing by that molar mass. When we're heading from moles back to grams, we're going to be multiplying by that molar mass. And then what we see up here is once we have converted to moles, we are then going to cross the bridge. We're going to use the mole ratio in order to change characters. Once we've changed characters or changed our little formula, who we're talking about, we're now ready to convert back to grams by multiplying by the molar mass of this new thing. So we're going to, like I said, we're going to start with what we're given in the problem. We're going to divide by its molar mass. We're going to look at the mole ratio given in the problem, and then we're going to multiply by the new molar mass, okay? All right, so let's go ahead and put this into play. So looking at our first problem, this is showing that we had 45.8 grams of nitrogen gas. This is our balanced equation. So a couple things to note is that we have nothing in front of this one, which is a 1. We have a 3, and we have a 2. So this means that it's a 1 to 3 to 2 ratio, right? So whenever we're asked to do the mole ratio, those are the numbers that we're going to be focusing on, right? So we're also talking about nitrogen gas, which is this guy right here, the N2, okay? So as you can see, that's the first part that comes down here into our problem. So we now have nitrogen gas right there. The ones that we've been dealing with here in class have looked a little bit more like this, okay? And we usually don't let you guys write into this box. So once we have what is given to us in the problem, we put that into that first spot. We're going to take those words and we're going to bring them down to the right. So you're going to see on your homework a little line that's bringing the units down, just a reminder, right? So we brought our units down, our units with the label. It's a double label thing. We have grams of this, and we're going to be converting to moles. So we're now at the part of the map where we are here. We are converting into moles by dividing by that molar mass. So this 28.02 is coming straight from our periodic table. If I zoom in on this, what we can see is that nitrogen over here has a 14.007. If I take my calculator and I say 14.007 times 2, I get 28.014, sorry. And that is exactly where this is coming from, okay? 28.02, they rounded. All right, so now we're in moles. So once again, we're going to grab those words. We're going to bring those down to the right, because this is going to tell us what order our mole ratio is going to be presented to us, right? So we took those words down to the right. So moles of nitrogen is down here. We know that this step right here is our mole ratio. So we're going to look right up here at our coefficients. So we put a 1 down here. We need to change into what they're asking for, which is the number of grams of hydrogen gas. So we want to get to hydrogen. Remember, we can't go from moles to nitrogen to grams. So we actually have to cross that bridge. Okay, so back again in Moletown, looking here, we have that little bridge. So we start as something, we change into something else. So here what we see is we're going to have our moles of hydrogen right there. Okay, we're going to once again treat this mole ratio. We're going to look at our coefficients. So we have the 3 right here. So that's what goes on top. Then we're going to take those words and we're going to bring them down to the right. Let me grab another color. Okay, so we have moles of hydrogen comes down to the right. So notice that is our first step. We don't even worry about the numbers until you have put all of your words in. Okay, that's the key. So we're going to pull that hydrogen, moles of hydrogen down to the right, and then we're back on the map. We are here in Moletown. We crossed the bridge. We're coming back to Gramland. So we need to multiply by the molar mass this time. So what we see happen here is the 1 mole comes down here, conversion, right? That's where the 1 goes. And then this number up here is going to be the molar mass, okay, where we pull from the periodic table. Hydrogen is 1.008, so we multiply that by 2, and that's where this 2.02 is coming from. Okay, now I do want to show you how this answer comes about, right? So when you have your calculator up and you're now at this step, you've filled in your whole railroad track, you've done all of your dimensional analysis needed. What we're going to do is we're going to go across the top. So we have 45.8. I'm going to multiply it by 1. So now I'm here. Now I'm going to multiply it by 3. Now I'm here. I'm going to multiply it by 2.02. I'm going to push enter. Okay, so I have 277.548, which is all of these things multiplied across the top. So now what we're going to do is we're going to start dividing the whole bottom. So now that we have like 3 things listed out, remember, we're going to push divide, divide, divide. And what that takes care of when you push divide over and over and over is you're technically multiplying everything across the bottom, right? So that's another way you could have done it, is we could have multiplied everything and divided the whole thing, right? But we're going to make this easy on us because in this virtual learning setting, we're going to just try to make the Google Calculator work for us as easy as possible. So once you've multiplied the whole top, now we're going to push divide. We're going to go 28.02, so I'm right here. I'm not going to push enter. I'm going to push divide again. I'm going to go to the next box, 1. I'm going to push divide again, next box, 1. So that means that if this wasn't a 1, let's just say it was like a 5, you could still do it this way. We're going to push enter, and now we get the correct answer, which is 9.905, and that's what we're seeing here. Okay, this last little box kind of rounded it weird, right? So remember, you got to kind of respect the significant figures that were given to us in the problem. So here what you see is we have 3 digits. So we're going to go ahead and go to 3 digits. The other way that you could do it is how many decimal places is it here? It's not really significant figure rules, but I think your teacher will be okay with it. So make sure you listen to whatever they're asking you to do. So here we have 3 significant figures, so 9.91 grams. All right, let's look at another example. So I'm just going to kind of zoom in here. Okay, so now we're going to do this one. So calculate the number of grams of water produced if you start with 100 grams of hydrogen. All right, so what I'd like to start with is how to use the problem. Okay, so let's figure out what they're saying calculate, right? So calculate or how much, right? These are 2 things kind of telling you what the goal is. So the number of grams of water, right? So I always, always, always expect you guys to either circle or put a square or underline what your goal is. That is what we need to get to. We need to come back to Grambling. That's what that says. And you start with, so I usually have us circle what we're looking for, underline what we have, which is the 100 grams of hydrogen. Okay, so what that just told you is that just told you that you are starting here in Gramland. We got to go to Moldtown, cross the bridge, and come back because we have to end back in Gramland, but as something totally different. So looking a little further, let's go ahead and see what we got. So I have a bunch of blank spaces. That means we got to handle a little bit of balancing first. So looking here, we can see, I'll go ahead and balance it over here. So I have H2 plus O2 yields H2O. Okay, so looking here, if I were to lay everything out, I'm using the line down the middle method. I have 2 hydrogens, 2 hydrogens, 2 oxygens, 1 oxygen. So that needs to get fixed. So I'm going to go ahead and throw in a 2 in front of the water. I'm going to recount. So now I have 4. And on this one, I have 2. All right, so that one got handled, but now we got to come back and fix the hydrogen over here. So we're going to double that, which makes it 4. So we have a 2, 1, 2. So we're going to go ahead and put those coefficients in here. It is so important that you have a balanced equation first. If you try to do it without a balanced equation, then you can't do this mole ratio step up here, right? Okay, so let's go ahead and start this railroad track. So I have 100 grams of hydrogen. So I'm going to go ahead and write 100 grams H2. Okay, all right. Remember, I'm taking the chemical formula right from up here, okay? All right, I'm going to take those words and I'm going to bring them down to the right. No matter what, you always do that, okay? So remember, we are in Gramland. We have to convert to the mole, okay? So we have to travel this way, okay? And we're dividing it by that molar mass. So we have mole of H2 that will be on top. I meant to write that in blue. I apologize. Just write that real quick in blue. There we go. All right. So what this ends up being, this is a conversion, right? So conversion goes in this next box always, which means we're saying 1 mole of something is equal to the molar mass, right? So the molar mass of 2 hydrogens, if we grab from our periodic table, 1.008, I'm going to take that, I'm going to multiply that by 2. So 1.008 times 2 gives me 2.016. So I'm going to go ahead and type or write in 2.016 for the molar mass. Okay, so we're ready to keep going. So we're going to have our next little part of our railroad track. So I'm going to bring those words down to the right. So moles of H2. Okay, if we refer to our little map, we're in mole town, so we're crossing the bridge. So we're going to mole, which is the mole ratio. Okay, so I'll kind of write that at the bottom in case you don't like the map. Well, I'll put mole ratio down here. So you do a conversion, then it's a mole ratio. Okay, and so we're converting into what we want, which is water, right? We can't go to grams yet, but we can go to moles of water. Okay, so because you took those words and brought them down to the right, that right there guarantees that you're going to put everything into the right spots. Okay, that's why we pressure you guys to bring your words down to the right. All right, so moles of H2O. All right, so now that we have that ready to go, let's go ahead and fill in what we got. So here the mole ratio, remember, is your coefficients, right? So we're going to look up here, and I have 2 moles of H2, and I have 2 moles of H2O. So if you're kind of thinking ahead, you look at that step and you're like, well, 2 divided by 2 is 1, and that is absolutely correct. And so you're going to see that really whenever you have 2 numbers on top of each other and they're the same, you kind of can leave them out. I'm not going to, but you definitely, that's great that you've noticed that, okay? All right, let's go ahead and bring our words down to the right again to kind of direct our method here. So we went to Mole Town, we crossed that bridge with the mole ratio, we used coefficients, so now we have to finish with a conversion, another conversion, right? Because we're going to convert back to grams. So we want to end with grams of H2O, right? So remember, in your conversion, it's always a 1 mole and a molar mass. So remember molar mass of water. We did this one a lot when we were doing our percent water in a hydrate. Let me, there it is. Okay, so we're going to go 1.008 times 2 plus 15.999, which is our oxygen. That's where I'm grabbing that from. Sorry, forgot to change our periodic table here. So 15.999. So our water is 18.015. So I'm going to go ahead and put that into our little railroad track here. All right, so when we go to type this all in, remember kind of what I did on the last one. We're going to go across the top. So first I'm going to start with 100 times a 1 times a 2 times an 18.015. I'm going to push enter. So now I'm going to push divide. So divided by 2.016. I'm going to push divide again, 2. Divide again, 1. Push enter. We get 893.60. Actually, I'll write the whole thing and then we'll figure it out. 893.601, blah, 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 blah. We started with 4 significant figures. It's good to kind of figure out what you've got there. So I have 1, 2, 3, 4 significant figures. So 893.6 grams of water is our answer. Okay, so now I want to finish with one more question, which is this one because of the wording on it. All right, so I wanted to point a couple things out. So this is how much carbon is required in grams. So we know that we're going to be doing that. So carbon in grams is what we're looking for. So we're going to circle that. Is to consume 5.67 grams of iron 3 oxide. There we go, iron 3. So, ooh, what a question. One thing I want you to notice is, first of all, it doesn't say calculate, right? So how much, that was one of the things to kind of cue in on as being your goal versus what they're giving to you. Second thing I want to point out is these are both reactants. So we're doing a reactant to reactant stoichiometry problem, which is really cool because we can always look at how they interact with each other as well, right? So if I have this much fuel, what do I need of the gas or something like that, right? So you're going to see that a lot in our combustion reactions that we're going to continue on with. All right, so for this one, obviously we need to have a balanced equation. So let's handle that first. So here I am seeing, let's see here, we got Fe, I have O, and I have C. All right, So on this side I have 2, 1, 3, 2, and then carbon I have a 1 and a 1. All right, so now that I have that set up, what I'm seeing is the iron is obviously off, but since that one's by itself, we're going to save that one for last. So what I'm going to actually fix is this oxygen deal. So what I'm going to do is I'm going to put a 2 in front of this. I'm going to recount. So now I have a 4, 2 times 2, and then a 2 times 3, which tells me a 6 of oxygen. I'm going to come over here. I'm going to fix this side. So I'm going to put a 3 in front of this. So now I have 3 carbon and 6 oxygen. So then I'm going to come back over here and I'm going to fix my carbon by putting a 3 in front of this one. And then I'm going to fix my iron by putting a 4 in front of it. Okay, so now we have a 2, 3, 4, 3. Okay, so when we go to dive into our actual stoichiometry problem, we're going to once again start with that 5.67 grams of Fe2O3. I'm going to go ahead and make my railroad track. Okay, and we're going to bring our words down to the right. So I'm going to bring down that grams of Fe2O3. Remember, this is our conversion step. So that means that we're going 1 mole, right? We're staying in the same character, which is the iron 3 oxide. So that means that we're going to have a 1 up top. And here is going to be our molar mass. So let's go ahead and grab that. So iron is 55.845 plus, and actually multiplied by 2, right? So we had our iron 3 oxide. So we have that. I'm going to push enter. I'm going to add it to now the 3 oxygens that we have. 159.66. Okay, so make sure you know how to get your molar mass. What I added together was 2 irons and 3 oxygens. So make sure you have that handy dandy periodic table. All right, so our number was 159.66 for the molar mass. Remember, that's your molar mass to 1 conversion. Okay, so I'm going to draw our next little line. We're going to take those words down to the right. So moles of Fe2O3. We're in Moletown, so we're already in moles, which means we're now going to change into our other character, which is what we're looking for, moles of carbon, right? This step right here, that is your mole ratio step, okay? Sorry, I ran out of room on the bottom. Keep writing ratio. All right, ratio, okay? So here we're looking at our coefficients. So I have a 2 with our Fe2O3, and I have a 3 with our carbon, okay? So I have a 2, and then I have a 3. Okay, so now I'm going to go ahead and bring my words down to the right one more time. And I'm going to be converting into grams of carbon. So remember, this step is your conversion again. Okay, where we have a 1 mole of carbon, and we go look up what its molar mass is on the periodic table. So carbon is right here, 12.011. Okay, and then to finish this off, we have, let me change my color, there we go. Okay, so to finish this off, we're going to go ahead and type this into our calculator. So I end up with 5.67 times 1, so I'm right here, times 3 times 12.011 equals, and I'm going to divide it now by everything on the bottom. So 159.66, I'm going to push divide again, 2, push divide one more time, 1, and now we end up with 0. Whatever it said, it just left my screen, hold on, 0.6398. So 0. I think I'm having some technical difficulties. Give me a second. Sorry. Sorry about that. Okay, so we'll finish this up. I had to give myself another slide so I had some more room. So we have that 0.6398. Okay, and looking up here, we started with 1, 2, 3 significant figures. So we're going to go 1, 2, 3. So we end up with 0.639. We round up, which will then change this to be 0.640 grams of carbon. And that's it. Okay, so just as a recap, we take whatever is given to us in the problem, right? So make sure you underline what we're going to be using and what your goal is. Make sure you have a balanced equation. You pull what is given to you in the problem, and that always goes in this first box. We're going to take those words down to the right. So you see that in red, we're talking about only iron 3 oxide. So you take the words down to the right. That sets you up for our conversion in the first step. So convert to moles. Then we bring the words down to the right again. That's where we're doing our mole ratio or our mole bridge, crossing the bridge, right? So we're going to pull all of that from our coefficients up in our balanced equation. Once you have that set up, and remember, words down to the right guarantees that it's going to go in the right direction. All right, we're changing into a different thing, so that's what I was trying to show with the blue color. So now we're talking about moles of carbon. We're going to bring moles of carbon down to the right, and we're going to convert back to grams by using that periodic table and the molar mass. And then we should get our answer. All right, that's all I got for you.